is the following a redox reaction? If some of this is strange, I would encourage you to go back and take a look at the previous lesson where we actually talk about assigning oxidation states. I write out the rules. I talk a little bit more in depth about oxidation reduction. This is just sort of a recap to get things going again. Okay, is the following a redox reaction? In other words, is it an oxidation reduction reaction? Some reactions are not. Some reactions are acid-base. There's no oxidation reduction going on. Some reactions, nothing changes. So a redox reaction is when there is a change in oxidation state from reactants to products. And you'll see what we mean in just a minute. In other words, do oxidation states change in going from reactant to product? That's it. Reactant to product. This is how you decide if a particular reaction is an oxidation-reduction reaction. You assign oxidation states to each thing in that equation, and then you check to see on both sides, the reactant, like the iron on the reactant side, the iron on the product side, has the oxidation state changed? If it has, it's an oxidation-reduction reaction. Electrons have been shifted around. Okay, so let's do 8H plus, and don't worry about how this looks. It's a perfectly good equation. MnO4 minus. This is what I was talking about. Some of these can look really weird. Don't let the symbolism scare you. So you're presented with this equation and you're asked, is the following an oxidation-reduction reaction? Well, I have to assign oxidation states. Let's do it, just like we did in just the previous example. H plus, the oxidation state on is +1. Permanganate, we said that the oxidation state was +7, and for oxygen is -2. Remember, -2 is always the same for oxygen. There's 4 of them for a total of -8. -8 plus 7 gives me a -1, so the manganese has an oxidation state of +7. Iron, well, the oxidation state is +2. Here, manganese, the oxidation state is +2. There you go. Manganese has gone from a 7 oxidation state, +7, to a +2. The oxidation state on manganese has changed. It doesn't matter that here it's with a compound, here it's alone. That doesn't matter. That's just chemistry. Iron is +3. Let me go back to blue. This is +3. Sure enough, iron has gone from a +2 oxidation state to a +3. Oxidation states have changed. Yes. Oxygen -2, hydrogen +1. This is a nonmetal. Hydrogen hasn't changed. Oxygen hasn't changed. Manganese has changed. The oxidation state has gone down. Iron has changed. The oxidation state has gone up. This is where the word reduction comes from. Oxidation, reduction means the number +7 to +2, the number is reduced from +7 to +2. It has gained electrons. Iron +2 to +3, it's been oxidized. Oxidation is actually an older term than reduction was. That's why we call it oxidation and reduction. That's why it doesn't seem to really jive all that well. +2, +3, this has been oxidized. Oxidation and reduction come in pairs. So you see, this is an oxidation reduction reaction. And the reason we know that, because oxidation states have been changed. One of them has gone down, one of them has gone up. It will always be that way. If one of them has gone down, I promise you somewhere something has gone up, because oxidation reduction comes in pairs. Okay,